A convex lens is used to form an image of an object on a screen when the upper half of the lens is painted with an opaque paint. We know that when a lens is covered, the part of a lens is covered, number of rays passing through the lens is decreasing. Therefore, intensity of image will decrease, but we can observe image at the corresponding space with the corresponding image distance. Therefore, we can get fourth one is the correct answer. Intensity of whole image will decrease. We can use that theory if a part of lens is covered, or if there is only one part of the lens, like this. A camera is used to take a close-up photograph of a person. If the distance between lens and film is 50 millimeters, the focal length of lens, it should be less than 50 millimeters. Because of we have to make a real image, we can make a real image for the convex lens if the object distance is greater than focal length. Therefore, we have to get second one is the correct answer. A convex lens of focal length 8 centimeters is placed 2 centimeters to the left of concave lens of the focal length 6 centimeters. A parallel monochromatic light beam of diameter 1 centimeter is incident on a convex lens from the left as shown in the figure. The emergent beam of concave lens field. There are two lenses. Focal length of first lens is 8 centimeters. It is a convex lens. Therefore, this light ray should be passing the point 8 centimeters from this first lens. But the gap between two lenses 2 centimeters. Therefore, this distance is 6 centimeters. It means 6 centimeters is the focal length of second lens. Therefore, this ray is moving towards the focal point of second lens. Therefore, this should be parallel to the main axis. Then we can get this one is the radius of the beam. This one is the radius of emitted beam. Radius of emitted beam is less than incident beam. Therefore, it should be parallel beam, diameter less than 1 centimeter. Answer is 4. An object is placed on the principal axis of convex lens, a ray of light PQ, which originates from the midpoint of P. On the object is drawn as shown in the figure. Which of the point A, B, C, D or E the correct continuation of ray PQ? Now we have to construct the ray diagram in original paper. Sometimes we will not be able to get correct answer by using given figure. You can remember the method. This one is focal point F2, and there is another focal point is this one. It is F1. This distance should be equal to this one. Now, I will consider the ray passing the pole from this incident point. It should be move without any deflection like this. And we can get parallel ray to the main axis. It should pass through the focal point like this. And now we can define image should be formed at this place. It is not this point. It means it is not the top of the object. Therefore, top of the object should be like this. Then we can get the given ray. It is passing a point like this. It also moving to this point. Therefore, we can get an approximate answer. C is the correct path. Then answer is C. Sometimes it will not pass correctly because of if you are not using original paper, there is a difference between ray diagrams. An object PQ is situated in front of a thin convex lens, and figure shows 4 rays of light drawn by a student starting from point Q of rays indicated with which will pass through the image of point Q. Then we have to do same thing. This one is the lens. We can draw ray diagram. The ray passing the pole will not deflect, and the parallel ray is passing the focal point. Then image should be like this, and we have to get we have to produce given ray stand. We have to find the corresponding ray which is passing this point. Now we have to get we can get answer is given as 4 A and C only. But we have to use the original diagram to get the correct answer. Which of the following ray diagram is incorrect? There are 5 convex lenses. When using a convex lens, the emergent rays should be pointed to a point, should be towards the point. It means we can get first one is correct. Parallel rays are pointed to a focal point. Second one also correct. Third one correct. In fourth one, rays are like this. Those are moving away from the main axis. We have to consider the deflection. From initial ray, those are moving away from the main axis. Then fourth one is the incorrect one. Answer is 4. 2 rays of light enter a box from one side and leaves as shown in the figure. The possible equipment, optical equipment inside the box is. We can decide the answer by using a ray diagram. We can use a convex lens to get these 2 rays. Then Again we can use another convex lens to get parallel rays. This is the correct ray diagram. Then we can use two convex lenses. Answer is 4. Focal length of convex lens is 5 centimeters. The magnitude of power of lens in diopters is. We know that lens power is 1 over focal length. 1 over focal length is given 5 centimeters. When getting answer in diopters, we have to convert focal length to meters. We have to divide by 100. 100 divided by 5, 20 diopters. Then answer is 5. Two thin lenses contact, focus the parallel beam of light to a point 10 centimeters away from the combination. The lens combination will be consist of. They have given focus point. It means focal length should be 10 centimeters of combination. We can use 1 over f equals 1 over f1 plus 1 over f2 for the lens combination. 1 over 10 is the focal length of combination. There are same values in answers, therefore we can get f as the focal length of one lens, one contact lens. Then we can find f value. 1 over 10 equals 2 over f. Then f is 20 centimeters. We can get two convex lenses of focal length 20 centimeters each. Answer is 5. As shown in the figure, a small object O and plane mirror are kept on the opposite side of convex lens. Focal length 0.5. Regarding the number of images formed and their nature, which of the following statements is correct? They have given focal length of this convex lens is 0.5 meters. Object distance is 1 meter. It means 2f. We know that when the object distance is 2f, we can see an image at same distance. It means 1 meter from the lens. This one is the image 1. This is the object. Then we can produce the corresponding ray diagram up to plane mirror. At the plane mirror, we know that there is another image formed by plane mirror. This distance is 1 meter. 1 meter from the plane mirror. This one is the image 2. The image 1 is passing rays directly. Therefore, this is a real image. This one is a virtual image. We can get image formed by the plane mirror to a point, to a plane. Then we can get reflection. When getting reflection by this lens, again we can observe another image at this place. We can find distance correctly, but it is not compulsory. This one also a real image. When 3 images two are real. 3 images, 2 are real. Then answer is 1.